All right, how do you handle vectors that are not in the same axis? Well, let's start with a simpler one. Let's say that you decide to go walking and you walk, let's go the opposite direction. So choose black here, and you walk I don't know, 4 kilometers to the left. And then you decide to say, well, okay, now I've got to go 3 kilometers to the north, or to up whatever that direction is. So 3 kilometers. Sorry, I didn't leave myself enough room. So 3 kilometers that direction. Then the question is, where are you? Excuse me, I'm considering a sneeze here. Question is, where are you? That's a great question. I guess the question really is, where did you end up relative to where you started, right? So that's represented by that vector right there. Okay. And I'm going to use, no, I don't want to use that. Hold on. I'm going to use a delta x to represent that value. Okay. So we need to find out that distance, and we also need to know this angle right here. So to find delta x, you cannot just add 4 plus 3. Again, 4 kilometers plus 3 kilometers is, of course, 7. And that has value. That's the distance you walked, right? You walked 4 plus 3 equals 7 kilometers. But that's not a vector. That's a scalar quantity. You walked that far. The vector distance is going to be the vector displacement, comparing where you stopped to where you started. Again, you stopped here, you started here. You stopped here, you started here. Well, that's going to be 5, right? Because it's a 3, 4, 5 triangle. And if it weren't, you'd use Pythagorean theorem. So you'd use the square root of 4 squared plus 3 squared, which would equal 5 kilometers. You ended up 5 kilometers from where you started. Say you're walking around San Francisco, and this is your hotel, and then you ended up going 4 kilometers down one street and 3 kilometers at right angles on another street. You ended up 5 kilometers eventually away from your hotel as the bird flies, right? The other thing we need, of course, is the angle. So to find that angle, in order to correctly describe this, you'd use trigonometry. You can either use tangent, which would be opposite over adjacent, 3 over 4 to find that angle. Now, the tangent of the angle would be 3/4, but that's not the angle. You could also use cosine, because you know adjacent and hypotenuse, because you just calculated the hypotenuse, 4 over 5 for cosine. Or you could use sine, which would be opposite over hypotenuse. I'm going to use tangent because I want to. So we write this as the, I'm not interested in the tangent, I'm interested in the angle, right? So you write this as the arctan, tan to the negative 1, of opposite over adjacent. The opposite side is 3, the adjacent side is 4. Again, in case you don't see that, here's the angle, there's the, it's opposite, 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 opposite. The adjacent side always touches the angle. So be sure you're in degree mode, and when you work this out, and again, don't forget the second function tangent, what we call the arctan, this comes out to be 37 degrees. All right, so this completely describes that vector. A different type of vector, let's say that you have a situation, let's change colors again, where you are pushing down with some force. Boy, that looks ugly. Let's try that one more time. So let's say you're pushing downwards with some force. Okay? And here are your component sides, component vectors. So this would be your y, the y force. This would be your x force. And let's go back to Brown for a second. This is the actual force. You are pushing, say you're trying to push a box across the floor with 60 newtons of force. Newton is the SI unit for force. About 4.5 newtons in 1 pound. And you're pushing down at an angle of 30 degrees. All right, so that angle right there is 30 degrees. Well, in order to solve problems, because we're going to end up combining these forces, we're going to end up solving problems that involve other forces, not just this one, not just the 60 newtons. We're going to need to figure out by how much are you pushing downwards, how much are you pushing down, and how much are you pushing over. Because you're pushing to the right, right? This box is going to, say it's going to slide on the surface to the right, but you're also pushing down a bit, right? You cannot put the 60 newtons into an equation in the x-axis because it's not solely, this brown arrow is not solely in the x-axis. It's not. It's downward and to the right. So the question is, how much of it's to the right? How much of that is to the right? That's a trig problem. You know the hypotenuse and you know the adjacent side. You know the hypotenuse and you know the adjacent. You're looking for the adjacent side. So you know the hypotenuse and you know the angle. You're looking for the adjacent side. I said that wrong, didn't I? Okay, so to find the adjacent side, fx, I'm going to use cosine. So the cosine of theta, the cosine of 30 in this case, equals opposite, which is fx, divided by the hypotenuse, which is 60. And so now I multiply both sides, right? Multiply both sides by 60 to get that from the numerator, and it cancels out. So both sides, numerator by 60 so that it cancels. And I end up, I'm going to just switch it around, so I end up with the fact that fx equals 60 times the cosine of 30. And let me just double check that on the calculator. Cosine of 60 is 0.866, but I'll multiply it out. Whoa, wait a second. Cosine of 60. Oh, gosh. Did I say cosine of 60? I meant cosine of 30. God, bad teacher. Bad. The force is 60. So cosine of 30 is 0.866 times 60 equals 52. Sorry about that. 52 newtons. And then to figure out the value of Fy, we're going to use sine, right? Because Fy is opposite the angle. So the sine of 30 degrees equals the opposite side. Again, Fy is opposite the angle all over the hypotenuse. The hypotenuse is F, which is 60 in this case, right? So let me just write that over here. Fy all over 60. So Fy equals 60 times the sine of 30 degrees, which I happen to know the sine of 30 degrees is a half, or 0.5. And so this comes out to be 30 newtons. So what these mean, as you push this box to the right and down with a force of 60 newtons, 52 newtons is to the right. 30 newtons is down. All right, that's vector mathematics.